Hello everyone, and welcome to today's presentation. I'm excited to have you here. Today, we'll be exploring the fundamentals of variables and data types. This is a crucial foundation for understanding programming. We'll start with an overview of what variables are, then dive into different data types and how they're used. So, let's get started and make this a productive session. So, how do we store coffee? Well, one simple way is to think of using a cup. Now, in programming, we often refer to a cup as a variable. A variable is basically like a container or a box that holds different kinds of information. These values, or the things we store inside our variables, can be numbers, text, or any characters you can think of. The key idea here is that variables help us organize and manage data efficiently, just like how a cup holds your coffee. This concept is fundamental because it allows us to work with different types of data in a flexible and organized way, which is essential as we build more complex programs. Let's talk about a common problem we encounter when working with variables. We know we can store values in a variable, right? But then, a natural question arises. How does the compiler actually know what type of data we're going to store in that variable? Well, this is where the concept of data types comes into play. Think of data types as a way to define the nature of the variable. They tell the compiler what kind of data the variable is meant to hold. Without data types, the compiler would be like a detective trying to guess what kind of data is hiding inside the variable. It needs some clues. So, by specifying the data type, we're essentially giving the compiler a clear instruction. This helps ensure that the data stored matches the expected format and that the operations on that data are valid. Understanding data types is fundamental because it helps us write more precise, efficient, and error-free code. It's a key part of how programming languages manage and organize data effectively. Now let's look at the different types of data types in C first. We have primitive data types. These are the basic building blocks in C, like int, float, char, and so on. They are predefined by the language and are used to store simple data values. Understanding these is essential because they form the foundation of any C program. Next, we have user-defined data types. These are types that we create ourselves to suit our specific needs. For example, we can define a structure to group related data or create an alias for an existing data type using typedef. This flexibility allows us to build more complex data models and make our code more organized and readable. Both of these categories, primitive and user-defined, are crucial because they help us manage and manipulate data effectively within our programs. Recognizing the difference between them and knowing how to use each appropriately is key to writing efficient and clear C code. Let's take a closer look at the primitype data type. These are the basic units used to define the static nature of a variable in programming. Essentially, they tell the computer what kind of data you want to store. For example, when you use int, you're indicating that the variable will hold an integer value, like 1, 2, or 100. Char is used for storing single characters, such as a or z. Float and double are both used for storing decimal numbers, but double provides more precision, making it suitable for more accurate calculations. Understanding these data types is fundamental because they form the foundation for how data is stored and manipulated in your programs. By choosing the correct data type, you ensure your program runs efficiently and accurately. Let's take a closer look at how to declare a variable in programming. For example, if we want to create a variable called num, we start by specifying the data type. In this case, it could be an integer, so we write int. Then, we give the variable a name, such as num. And finally, we end the declaration with a semicolon. This syntax, data type variable name semicolon, is fundamental because it tells the compiler or interpreter what kind of data the variable will hold and what it's called. Remember, understanding this structure is essential as it forms the basis for working with data in any programming language. So, how do you use a variable in C? Well, the first step is to initialize it. Initialization simply means giving the variable a value so it has something to store. Think of it like assigning a starting point for your data. Now, unlike some other languages like Java, C doesn't have built-in memory management. That means when you declare a variable in C, it doesn't automatically have a specific value. Instead, it contains what's called a garbage value, random data that was there before. So, it's really important to initialize your variables right after declaring them to ensure you're working with known, predictable data. This step is crucial because it helps prevent bugs and makes your program behave consistently. Remember, initializing your variables is fundamental to managing data properly in C. Now, let's look at some practice questions to solidify what we've learned. Imagine you're a shopkeeper and you want to write a simple C program to store details about items. The key here is to use variables for item number, item name, and item value. You would take input from the user through the screen and then display that information in a formatted way. This helps us understand how to handle user input and output in C. For the challenge task, we're asked to write a program that takes a person's name as input and then displays a friendly greeting. It's important to pay attention to how we prompt the user, how we store the input, and how we display the output in a conversational, personalized message. For example, after entering your name, the program should say, "Hello, Ram. Nice to meet you." These exercises are great because they connect directly to real-world applications, like creating simple interfaces or data entry forms. They also reinforce the core concepts of variables, input, output, and formatting, which are foundational in programming. By practicing these tasks, you'll develop a better understanding of how to interact with users and manage data effectively in your programs. This is a crucial step toward building more complex and user-friendly applications. Thank you so much for your time and attention today. I really appreciate the opportunity to share these insights with you. Remember, the key takeaways are about understanding the core concepts we've discussed and how they connect to the bigger picture. I hope you found this presentation both informative and inspiring. If you have any questions or want to explore any topics further, please feel free to reach out. Thanks again, and I look forward to connecting with all of you soon.